NEC 695.5 addresses sizing a transformer when supplying a pump from a single source. It generally requires 125% of the pump load plus 100% of any other load. When two sources are used with a transfer switch, 695.5 cone covers the sizing and mirrors 695.5A. However, 695.5 C2 introduces an additional stipulation, mandating compliance with 450.3 and Table 450.3 for protection by overcurrent devices sized to carry locked rotor current. This often necessitates increasing the transformer size so the upsized overcurrent device is protected per 450.3, especially when the other load is minimal. The reason for this additional requirement in NEC 695.5 C2 for dual-fed pump systems stems from the distinct operating characteristics of the transfer switch and the potential for elevated locked rotor current and starting current. Let's examine single-feed pump systems and dual-fed pump systems to understand why. In a single-feed pump system, the transformer directly supplies the pump and any auxiliary loads. The transformer's capacity is designed to accommodate the full locked rotor current and starting current of the pump, along with any other connected loads. The overcurrent devices employed to safeguard the transformer are sized to handle the entire locked rotor current, adhering to NEC 450.3. In contrast, a dual-fed pump system utilizes a transfer switch to supply the pump. In the event of a power source failure, the transfer switch automatically switches the pump load to the secondary source. During this transfer process, there's a brief period where the pump could draw locked rotor current from both sources concurrently. To account for this potential increase in locked rotor current during the transfer, NEC 695.5 C2 mandates that the transformer's sizing must satisfy both the single-feed requirements of 695.5 cone and the requirements outlined in NEC 450.3 and Table 450.3a. This dual compliance ensures, firstly, that the transformer can endure the heightened locked rotor current during the transfer operation, and secondly, the overcurrent devices protecting the transformer are appropriately sized to manage this increased locked rotor current, thereby maintaining adequate short-circuit and overload protection. Without the additional stipulation in 695.5 C2, the transformer may be undersized, rendering it incapable of managing the elevated locked rotor current during the transfer. This could potentially lead to transformer failure and the subsequent loss of the fire pump functionality. In essence, the NEC prioritizes the reliable operation of fire pumps, especially in dual-fed systems where the transition between power sources introduces a unique electrical demand. The additional sizing requirement ensures that the transformer and its protective devices are robust enough to handle the transient conditions during power transfer, guaranteeing the fire pump's availability when it's needed most. The locked rotor current is the maximum current drawn by an electric motor when it is initially energized but the rotor is not yet turning. Its current can be significantly higher than the motor's normal full load current, often 6 to 8 times greater. Overcurrent devices are electrical safety devices designed to interrupt a circuit when the current exceeds a predetermined safe level. This protects equipment and personnel from damage or injury due to overloads or short circuits. A transfer switch is an electrical device that automatically switches a load from one power source to another. This is commonly used in emergency systems such as fire pumps to ensure a continuous power supply in case of a primary power source failure. NEC Article 450 covers the requirements for transformers, including their overcurrent protection. Table 450.3 specifically provides guidance on the maximum overcurrent protection allowed for transformers based on their voltage and impedance. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installations in the United States. It is updated every 3 years to reflect the latest advancements and best practices in electrical safety. When sizing a transformer, it's important to consider all connected loads, including both continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time, while non-continuous loads operate for shorter durations. The NEC requires that continuous loads be factored in at 125% of their full load current when determining the required transformer capacity. This ensures that the transformer is not overloaded during sustained operation. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations. It's essential to consult with a qualified electrical engineer or contractor to ensure compliance with all applicable codes and standards. The impedance of a transformer is a measure of its opposition to the flow of alternating current. It is an important factor in determining the transformer's short-circuit current capability. A lower impedance transformer will have a high short-circuit current capability, which means it can deliver more current during a fault condition. However, a lower impedance transformer may also require larger overcurrent devices to protect it from damage. The voltage rating of a transformer is the maximum voltage that it is designed to operate at. It's important to select a transformer with a voltage rating that matches the voltage of the power source and the voltage requirements of the connected loads. Using a transformer with an incorrect voltage rating can damage the transformer and the connected equipment. The kVA rating of a transformer is a measure of its apparent power capacity. It is calculated by multiplying the voltage and current ratings of the transformer. The kVA rating should be sufficient to supply all connected loads, including any future loads that may be added. The temperature rating of a transformer is the maximum temperature that it can operate up without damage. It's important to select a transformer with a temperature rating that is suitable for the ambient temperature of the installation environment. Operating a transformer above its temperature rating can shorten its lifespan and potentially lead to failure. The efficiency of a transformer is the ratio of its output power to its input power. A higher efficiency transformer will consume less energy and generate less heat. When selecting a transformer, it's important to consider its efficiency rating to minimize energy costs and environmental impact. The insulation rating of a transformer is a measure of its ability to withstand high voltages without breakdown. It's important to select a transformer with an insulation rating that is appropriate for the voltage levels in the installation environment. Insufficient insulation can lead to electrical arcing and potential hazards. The core of a transformer is the magnetic circuit that provides a path for the magnetic flux. The core is typically made of laminated steel to reduce eddy current losses. The design and material of the core can significantly affect the performance and efficiency of the transformer. The windings of a transformer are the coils of wire that carry the current. The primary winding is connected to the power source, while the secondary winding is connected to the load. The ratio of the number of turns in the primary and secondary windings determines the voltage transformation ratio of the transformer. The bushings of a transformer are the insulated terminals that connect the windings to the external circuits. The bushings must be properly sized and rated to handle the voltage and current levels in the installation. The tap changes of a transformer allow the voltage transformation ratio to be adjusted. This can be useful for compensating for voltage variations in the power source or for optimizing the voltage supplied to the load. The cooling system of a transformer is designed to remove heat generated by the core and windings. Transformers can be cooled by air, oil, or other methods. The type of cooling system required depends on the size and operating conditions of the transformer. The enclosure of a transformer protects the internal components from the environment. The enclosure must be suitable for the location of the installation, whether it is indoors or outdoors. Outdoor enclosures must be weatherproof and corrosion resistant. The grounding of a transformer is an important safety measure that helps to prevent electrical shock hazards. The transformer should be grounded according to the requirements of the NEC and other applicable codes. The maintenance of a transformer is essential for ensuring its reliable operation. Regular maintenance should include inspections, cleaning, and testing. Any problems should be addressed promptly to prevent further damage or failure. When troubleshooting a transformer, it's important to follow a systematic approach. This may involve checking the voltage, current, and temperature of the transformer, as well as inspecting the internal components for damage. The NEC provides specific guidelines for the installation and protection of transformers. It's important to follow these guidelines to ensure safe and reliable installation. NEC Article 455 covers the requirements for phase converters, which are used to convert single-phase power to three-phase power. Phase converters can be used to supply three-phase motors and other equipment in locations where only single-phase power is available. NEC Article 470 covers the requirements for electrical heating appliances. This article includes requirements for the overcurrent protection, grounding, and wiring of electrical heating appliances. NEC Article 480 covers the requirements for storage batteries. This article includes requirements for the location, ventilation, and protection of storage batteries. NEC Article 490 covers the requirements for equipment over 600 volts nominal. This article includes requirements for the design, installation, and testing of high-voltage equipment. NEC Article 500 covers the requirements for hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. This article includes requirements for the type of equipment that can be used in hazardous locations and the installation methods that must be followed. NEC Article 501 covers the requirements for Class I locations. Class I locations are hazardous locations where flammable gases or vapors may be present. NEC Article 502 covers the requirements for Class Roman II locations. Class Roman II locations are hazardous locations where combustible dust may be present. NEC Article 503 covers the requirements for Class Roman III locations. Class Roman III locations are hazardous locations where easily ignitable fibers or flames may be present. NEC Article 504 covers the requirements for intrinsically safe systems. Intrinsically safe systems are electrical systems that are designed to be incapable of causing ignition in a hazardous location. NEC Article 505 covers the requirements for Zone 0, Zone 1, and Zone 2 locations. These zones are classifications of hazardous locations based on the frequency and duration of the presence of flammable gases or vapors. NEC Article 510 covers the requirements for hazardous locations specific. This article provides additional requirements for specific types of hazardous locations, such as gasoline dispensing and service stations, aircraft hangars, and healthcare facilities. NEC Article 511 covers the requirements for commercial garages, repair, and storage. This article includes requirements for the wiring methods, equipment, and ventilation in commercial garages. NEC Article 513 covers the requirements for aircraft hangars. This article includes requirements for the wiring methods, equipment, and fire protection systems in aircraft hangars. NEC Article 514 covers the requirements for gasoline dispensing and service stations. This article includes requirements for the wiring methods, equipment, and ventilation in gasoline dispensing and service stations. NEC Article 515 covers the requirements for bulk storage plants. This article includes requirements for the wiring methods, equipment, and fire protection systems in bulk storage plants. NEC Article 516 covers the requirements for finishing processes. This article includes requirements for the wiring methods, equipment, and ventilation in finishing processes, such as painting and spraying. NEC Article 517 covers the requirements for healthcare facilities. This article includes requirements for the wiring methods, equipment, and emergency power systems in healthcare facilities. NEC Article 518 covers the requirements for places of assembly. This article includes requirements for the wiring methods, emergency lighting, and fire alarm systems in places of assembly, such as theaters, auditoriums, and churches. NEC Article 520 covers the requirements for theaters, audience areas of motion picture and television studios, and similar locations. This article includes requirements for the wiring methods, stage lighting, and special effects equipment in these locations. NEC Article 525 covers the requirements for carnivals, circuses, fairs, and similar events. This article includes requirements for the wiring methods, grounding, and safety of electrical equipment used at these events. NEC Article 530 covers the requirements for motion picture and television studios and similar locations. This article includes requirements for the wiring methods, stage lighting, and special effects equipment in these locations. NEC Article 540 covers the requirements for motion picture projection rooms. This article includes requirements for the wiring methods, equipment, and ventilation in motion picture projection rooms. NEC Article 547 covers the requirements for agricultural buildings. This article includes requirements for the wiring methods, grounding, and equipotential planes in agricultural buildings. NEC Article 550 covers the requirements for mobile homes, manufactured homes, and mobile home parks. This article includes requirements for the wiring methods, grounding, and overcurrent protection in these installations. NEC Article 551 covers the requirements for recreational vehicles and recreational vehicle parks. This article includes requirements for the wiring methods, grounding, and overcurrent protection in these installations. NEC Article 552 covers the requirements for park trailers. This article includes requirements for the wiring methods, grounding, and overcurrent protection in park trailers. NEC Article 600 covers the requirements for electric signs and outline lighting. This article includes requirements for the wiring methods, grounding, and overcurrent protection of electric signs and outline lighting systems. NEC Article 604 covers the requirements for manufactured wiring systems. This article includes requirements for the construction, installation, and testing of manufactured wiring systems. NEC Article 605 covers the requirements for office furnishings. This article includes requirements for the wiring methods and grounding of electrical equipment in office furnishings. NEC Article 610 covers the requirements for cranes and hoists. This article includes requirements for the wiring methods, grounding, and overcurrent protection of cranes and hoists. NEC Article 620 covers the requirements for elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. This article includes requirements for the wiring methods, grounding, and overcurrent protection of these systems. NEC Article 625 covers the requirements for electric vehicle charging systems. This article includes requirements for the wiring methods, grounding, and overcurrent protection of electric vehicle charging systems. NEC Article 626 covers the requirements for inter-system bonding terminations. This article includes requirements for the bonding of different electrical systems such as power, telephone, and cable television systems. NEC Article 640 covers the requirements for audio signal processing, amplification, and reproduction equipment. This article includes requirements for wiring methods, grounding, and overcurrent protection of audio equipment. NEC Article 645 covers the requirements for information technology equipment. This article includes requirements for the wiring methods, grounding, and overcurrent protection of information technology equipment. NEC Article 646 covers the requirements for modular data centers. This article includes requirements for the wiring methods, grounding, and overcurrent protection of modular data centers. NEC Article 647 covers the requirements for sensitive electronic equipment. This article includes requirements for the wiring methods, grounding, and overcurrent protection of sensitive electronic equipment. NEC Article 660 covers the requirements for X-ray equipment. This article includes requirements for the wiring methods, grounding, and safety of X-ray equipment. NEC Article 665 covers the requirements for induction and dielectric heating equipment. This article includes requirements for the wiring methods, grounding, and safety of induction and dielectric heating equipment. NEC Article 668 covers the requirements for electrolytic cells. This article includes requirements for the wiring methods, grounding, and safety of electrolytic cells. NEC Article 669 covers the requirements for electroplating. This article includes requirements for the wiring methods, grounding, and safety of electroplating equipment. NEC Article 670 covers the requirements for industrial machinery. This article includes requirements for the wiring methods, grounding, and overcurrent protection of industrial machinery. NEC Article 675 covers the requirements for electrically driven or controlled irrigation machines. This article includes requirements for the wiring methods, grounding, and overcurrent protection of irrigation machines. NEC Article 680 covers the requirements for swimming pools, fountains, and similar installations. This article includes requirements for the wiring methods, grounding, and bonding of electrical equipment in these installations. NEC Article 682 covers the requirements for natural and artificially made bodies of water. This article includes requirements for the wiring methods, grounding, and bonding of electrical equipment in and around these bodies of water. NEC Article 685 covers the requirements for integrated electrical systems. This article includes requirements for the design, installation, and operation of integrated electrical systems. NEC Article 690 covers the requirements for solar photovoltaic systems. This article includes requirements for the wiring methods, grounding, and overcurrent protection of solar photovoltaic systems. NEC Article 700 covers the requirements for emergency systems. This article includes requirements for the design, installation, and testing of emergency systems such as emergency lighting and fire pumps. NEC Article 701 covers the requirements for legally required standby systems. This article includes requirements for the design, installation, and testing of legally required standby systems, such as those required for hospitals and other essential facilities. NEC Article 702 covers the requirements for optional standby systems. This article includes requirements for the design, installation, and testing of optional standby systems, such as those used for convenience or to protect against economic losses. NEC Article 705 covers the requirements for interconnected electric power production sources. This article includes requirements for the interconnection of different electric power production sources, such as solar photovoltaic systems and wind turbines. NEC Article 708 covers the requirements for critical operations power systems. This article includes requirements for the design, installation, and testing of critical operations power systems, such as those used for data centers and other critical facilities. NEC Article 720 covers the requirements for circuits and equipment operating at less than 50 volts. This article includes requirements for the wiring methods, overcurrent protection, and grounding of low-voltage circuits. NEC Article 725 covers the requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. This article includes requirements for the wiring methods, overcurrent protection, and grounding of these circuits. NEC Article 727 covers the requirements for instrumentation tray cable type ITC. This article includes requirements for the construction, installation, and use of instrumentation tray cable. NEC Article 760 covers the requirements for fire alarm systems. This article includes requirements for the wiring methods, overcurrent protection, and grounding of fire alarm systems. NEC Article 770 covers the requirements for optical fiber cables and raceways. This article includes requirements for the installation and protection of optical fiber cables and raceways. NEC Article 800 covers the requirements for communications circuits. This article includes requirements for the wiring methods, grounding, and protection of communications circuits such as telephone and data networks. NEC Article 810 covers the requirements for antenna systems. This article includes requirements for the installation and grounding of antenna systems for radio and television reception. NEC Article 820 covers the requirements for community antenna television and radio distribution systems. This article includes requirements for the wiring methods, grounding, and protection of CAT-EV systems. NEC Article 830 covers the requirements for network-powered broadband communications systems. This article includes requirements for the wiring methods, grounding, and protection of network-powered broadband communications systems. NEC Article 840 covers the requirements for premises-powered broadband communications systems. This article includes requirements for the wiring methods, grounding, and protection of premises powered broadband communications systems. The application of these NEC articles will ensure a safer and more reliable electrical system.